Having now learned the method of integration by substitution, we're going to use that method to derive formulas for integrating these two special types of functions, right? F of x raised to the n times f prime x, as well as f prime x over f of x. And then having derived formulas for these, we'll be able to integrate functions that are in either of these two forms quickly in maybe 1 or 2 steps depending on the question. So let's start with the first one. We're integrating f of x raised to some number n times f prime x with respect to x. To do the integration, we're going to use substitution. So I'm going to say let u be equal to f of x. I'm going to differentiate the u with respect to x, and then I'm going to transpose the dx. So I'm going to end up with f prime x dx. So now we have this part here being du. This is u, and so we're going to have u raised to the n, all right? Which means this becomes the integration of u to the n du. And that's something that we know how to integrate simply enough. U to the n plus 1 over n plus or c. And of course, you need to remember to replace your u with, in this case, f of x. So f of x raised to the n plus 1 over, oh sorry, I left off my n plus 1 over here, so it's over n plus 1, right? So basically what this is saying, and you'll see in the example, if you have a function being raised to a power being multiplied by the derivative of the function, right, then all you need to do, your answer, you don't need to go through the steps of using substitution. You can, but what you can do is to quickly arrive at your answer by adding 1 to the power of the f of x and then dividing by that new power. So let's look at an example. Let's say I was asked to integrate sine x or sine squared x times cos x. All right, so here we're integrating sine squared x cos x. This is not a standard integral. It's not in our table. And none of the methods that we've learned would work except the substitution method. The substitution method would work here. But having this formula now, knowing that when we integrate a function raised to a power that is being multiplied by its derivative, all we need to do is to take the function and add 1 to the power and divide by the new power. I can apply that to this question. Here my f of x would be sine x. So I have f of x, right, raised to a power of 2, so my n is 2, and being multiplied by the derivative of the function, the derivative of the f of x. The derivative of sine x is cos x. So sine x times cos x, right? So here we have it in this form. We have f of x raised to a power being multiplied by the derivative of f of x. And in that case, we can quickly arrive at our answer by simply taking the f of x, which in this case is sine x, adding 1 to the power. So that would give us 3. So that's sine cube x. And dividing by that same power plus c. So it's a nice little way to quickly arrive at your answer without going through the steps of substitution. For the second one, if you are integrating f prime x over f of x, and you should be able to guess at the answer for this one based on when you differentiated, right? What did you differentiate and get something like this? You should know. But anyhow, let's use substitution to derive the formula. So we're going to say let u be equal to the f of x We're going to differentiate the u with respect to x and then transpose the dx. That gives me f prime x dx. And so the f prime x dx here will be du, and this f of x here is u. So this becomes the integral of du over u. Or in other words, the integral of 1 over u du. And we know when we integrate 1 over u, we're going to get ln u plus c. And then we have to replace our u, which is going to give me ln f of x plus c. And that is what you should have expected, because we know from doing differentiation that when you differentiate ln of a function, you get f prime x over f of x, right? So the derivative of the function over the function itself. And what this allows me to do now is to quickly arrive at the answers for certain questions. So let's take a nice and simple example. Let's say we have the integration of, I'll use sine and cos again. So I'll say cot x, right? It may not be apparent here, but we know cot x is cos x over sine x. So I would take a question like this and I would rewrite it as cos x over sine x. And then I would see that this formula now comes into play. In my denominator, I have a function, and in the numerator, I have the derivative of that function. So I have f of x in the denominator and f prime x in the numerator. According to the formula, I'm going to get ln of the denominator. So ln of sine x plus c. All right. Let's look at some more examples.